So now we've got our player idling on the spot. He's ready for whatever action we tell him to do. He just doesn't have the ability to do them yet. So let's change that. It's time to let our character walk around the level and also be able to jump into the air. So the first thing that we're going to do is change that damn text size. It's ridiculously massive. It should be smaller, and I intend to change that. And then we're going to go into our Game 1 class and load up another texture, which we're going to call public static texture 2D. I don't even know how I came up with a U instead of an S. And we're going to call this one SPR character reacts. So the first one was called attacks because it had all the animations for attacks on there. But this one here, let's just bring it up for a moment, character reacts because it's got all the reactive ones. If you get hit, you ouch, you react to it. If you get knocked down, oh, you fall onto the ground, then you get back up. You're reacting to being hit. And I didn't really know how to get a better name for everything else in here because he kicks at something on the ground, he picks up an item, stands there with his arms folded, and then he jumps. So, yeah. Unless you can think of a cool word that combines all of those into one, like other, but then the other one should be called other as well because it's got walking and attacks in there and throwing knives. So, ooh, what would you call it? We're just going to call it reacts. What we want to focus on in this one is the jumping. So let's zoom in, is on the jumping, but we'll get into that in just a moment. Back in here into our actor class, we're going to add in an enum called direction, and we're going to give this one two directions, left and right. Then we're going to need to set it up to use it, so we'll put in here public facing dir. Facing dir meaning facing direction. And we're not going to set it in the constructor. That's going to be set in some other spot. So let's look at our player class now. I could keep going with plenty of space, but I'm going to run out of space and probably use 2 or 3 sheets on the player anyway. So let's make it on a new one. Player needs to have an enum for player state. Well, it does need to have, it's already got one. We're going to add these onto it. We're going to add in walking and jumping. And then we're going to need to add in 2 more draw widths for our constants. So const int draw width walk, which is going to be equal to 124, and const int draw width jump, which is 66, less than 100, very small. Now what we need to do is add in some more fields onto our player. So let's put these ones here under movement, and we're going to put in an vector 2 for jumping pos, and we're also going to need to know our landing height. So float landing height, Height. And what are these two things? Don't we already have a position for our actor? Well, yeah, we do, but what that does is determines where it is on the ground and draws the shadow there and draws our actor, little man, fighting little man. Hey, he's not as beefy as that last dude, was he? No way, he had massive shoulders. Anyway, so there's our position there. Well, I guess our position would actually be here at the bottom, wouldn't it? Because of the origins. So let's just pretend that was supposed to be done like that. There we go. There's our position at the bottom center of the actor and of the shadow. Okay, but if we jump in the air, let's look at our animation for a moment. Here we go. Look at it. It's on the base, and it's always on the bottom. If you just jumped like that, somehow you'd be just raising your legs into the air, your knees, and your body would just be staying kind of stationary. And that would look kind of strange. So I guess it would look pretty cool if you can do your legs up and down that pretty quick, but then that's going to be done a lot faster than 12 frames per second. which would look kind of strange, particularly for a jump, and then throwing a kick in there as well. That's pretty quick. That's very quick. So what we do is we have, if we press the jump button, then our position of our player, okay, it changes over to use the jumping position. And so when we jump, we've got our actor could be up here in the air. Whoop. Wow. Like a Matrix kind of person. Ready to kick someone out. They're a lot higher off the ground there, so their new position would be up here. There's our current actor position, and here's our player's position. It gets higher. And that way we can also, our shadow will always stay on the ground instead of following us into the air as we jump, which would look particularly strange if we were jumping sideways, like if we were moving along the ground, then we press jumps, and we went, Hua! Our shadow would be coming up, and down with us, which would look really strange, and our player would be here in the air. We need the shadow to always stay on the ground, and our player can jump into the air. So that's why we use a jumping position. A landing height is so when we're coming back down, we can, have we landed? Yes, we have. Alrighty-o, let's reset the idle graphic. And that will be what we need for our movement. So let's check out our update call. Scrolling down a bit here, and just going to the right spot on my notes. Rightio, let's put in public void update. I nearly said static, that would have been very wrong. Which takes in our game time. And we've got our switch based off state. Close that off. And we've got case dot player, oh, it's not case dot, it's case player state dot idle. Why are you writing all that out again? Well, because we're going to add to it. Player state dot walking. They're both on the same one. Now, if we're doing that, we check for the jump key. Or jump button if you're using a gamepad. Was jump button pressed? And if it was, what do we do? Well, we need to make sure our animation is going to be drawing the jumping one. So we set up jump animation, and we set the state. Set player state equal to player state dot jumping. But of course we don't set player state there, we set just the state, so I'm going to get rid of that. And put in a state. Whoa. There we go. State equal to player state dot jumping. And we set the draw area, which is all in the jumping animation. What else do we do here? We set our speed. Ooh, I missed one up here. Whoops. Ha! Very bad. Vector 2 speed. What does our speed do? Is it tells us how high are we jumping. What doesn't it? It tells us how fast are we jumping. Pachoo! And back down. And gravity takes care of that one. Tells us how fast we're moving up across the screen, or up and down when we're not jumping as well. So, whoops. We'll set the speed. Speed.y equals, I'm going to use -5 for our first jump into the air. There we go. And that's our jump speed. Anything else we do here? Yeah, we better call return. Because we've just jumped. What happens next is, if we didn't press the jump key, it would go to call our move method. Game time. Which would then decide to draw the idle or walking animation, which wouldn't be very cool if we were in here. If we just set up the jump animation, we press move, then we'd have the complete wrong frame getting drawn. It would look rather strange. So we call return, make sure we skip out of that one. And then we go on to breaking this one off. And let's look at our jumping one. So case player state dot jumping. And what do we need to add into our case here? Well, first off, we move our jumping position. By speed. Check it out, we never take input if we're in jumping, for movement input anyway. So if you've just been moving along the ground and you've got the thumbstick held in the direction of right. So you're walking along the ground here, and you press jump, and you've still got that right thumbstick held down. Your speed is set to be sideways there. Only when we change in here is just the Y. So that's going to give you a new vector of this direction, and you go jump. That way, players in the air, they can't suddenly decide, oh no, I want to jump back to the left, and flick the stick over to the left and go jump, and boom, land there. Because I think that looks kind of strange, and I don't want that miss. So I'm not going to put it in there. You can put it in if you'd like, but it's not going in my version that I'm making. So that'll be that one there. We'd better update the jumping pos and the speed, and then we'd better slow down our speed a little bit. So speed dot y plus equal to 0.3. I think I'll probably use for my gravity. So that way there, we want to make sure as we're going up our speed gets slower, and as we're coming down our speed gets faster, so that we've got gravity looking like it's taking control of things. And then we check if we've gone too low. So have we landed? How could we check that? Well, we could check jumping position against our landing height, and if we've just come down, no, yes, we've landed. Okay, our jumping position is less than, or it would be bigger than in our case, wouldn't it? Is it bigger than or equal to our landing height? Well, then we've landed. So then we better go ahead and make ourselves land, which would mean stopping our speed, speed.y equal to 0, and we'd better reset our idle graphic. Boom. That takes care of you. Finishes off, break. But if we haven't landed, then I'm out of space. If we haven't landed, then we should animate our jump. I put break. Why did I put break? No, go away, go away. I didn't say that. That just finishes off the if statement. If we have landed, then we need to, if we have not landed, then that means we're still jumping, and we need to make sure that we're constraining ourselves to the screen. I'm out of space here, so I'm just going to take this guy here up to here. And what do? Then we'd better constrain to screen, because we could be moving sideways. To screen. I've got a method called that coming up soon, so I'm not going to pseudo code that out. And then we're going to animate jump as well. Which takes in-game time. Because if we're jumping, we'd better be animating the jump. And that finishes off you. Now we can put in a break. Break. And finish off our switch statement. And our update. There we go. And that was all lodged under there. Sorry guys, ran out of space on this one, so let's go back up to the top and make a new layer and hide you. And look at what we're going to do with our move call, which we do with a private void move, which takes in game time. And what do? Well, we'd better check out for our input. But we can't just do up, down, left, right all together. We've got to separate them. And let's take a look-see at that. Let's say if, oh, let's not put if, let's put any X movement input. And if there is, then we'd better do some things. So we'll set up our speed. Set X speed. And then we'll set our facing direction as well. Set facing dir. Facing dir could be left or right, depending on which way we've pushed our stick or our keyboard button, I should say, if we press left or right. And our speed could be plus or minus, depending on as well. There we go. And we need to set ourselves to walking. State to walking. And we better set our draw width as well. Set draw equal to draw width. Walking. Well, why are we only setting the draw width equal to walking? Why aren't we also setting up the rest of the animation like we've done with everything else? You know, when we called reset idle graphic, we told x is equal to frame x equal to 0, frame y is equal to 0, draw width is equal to that, draw height is equal to this 165, draw height normal. And that's because we've got 2 lines for our animation here, and we can't quite tell it, okay, set frame x equal to 1, so 1, and do that, because if we loop the animation here, we're going to boop that frame there, loop back to here, which doesn't loop too well. We need it to go across and, okay, go to the next one, across here, finished. Now we can loop, because those ones loop okay, the bottom right and the bottom left of that particular area there. So we're not going to do any kind of stuff in there. That is all taken care of in the draw, or animate walking animation itself. Getting tongue-tied with all these things. Okay, so we're going to just set that for both left and right. There's going to be 1, and then we're going to copy that again for else other direction input. Saves me writing all that out again. That's for blah blah blah. So that'll be 1 for left, which would be left would be minus, and our other x movement would be, if we tap it over to the right, well then we know set facing direction will be to the right, and our speed will be equal to plus, but these two here would be the same. So what we're going to do then is, if there is no x in left and x in right, then we can put in another else, which means we're going to be on idle. So we'll just set speed equal to 0. Speed dot y equal to 0. Is it y? There, x. Speed dot x is equal to 0. Okay, that takes care of you. Now we'll check for any y input. So that finishes off that if statement. That's x. X is done. It is finished. It goes from here to here. Now we're looking at the y movement separately. Here down to, I'm going to guess, there. See how close I can guess that one. And we'll put any y movement input. Well, if there is, what do we need to do? Let's just say as above, because most of it's similar. We're not going to be playing with our facing direction, but we do set our speed, our y speed, to be plus or minus up or down as we need to, so well, we may as well write that one in. Set speed plus minus. There we go. And we'll do that for both up and down. And if there is no up or down, then we can say else speed dot y equal to 0, and finish that one there. If I've gone a little bit lower, so let's put there. Y movement goes from there to there. Okay. There we go. Someone's probably got to be wondering, why are you pseudocoding this? Why aren't you writing everything out for us? Well, I want to give you the ability to, if you wanted to, after you've finished looking at these implementations, press pause, and see if you can code the entire thing out yourself. See if you can figure out the code. And if you get stuck, go to the next code videos. That's why I'm doing all these kind of pseudo-coding, not writing everything in as exactly as it's going to be. Okay, so, whoa, too low, you. If our speed is equal to 0, how do we know what animation to do? We've never actually called animate walking or animate idle yet. Now, we do that by checking for our speed. So we say if, I wish you can write this one out, if speed equal to vector 2 dot 0, 0, 0. If speed is equal to 0, that means we are idling. So we're going to put in here, make character idle. And there's a few things we need to do in there. We need to make sure our draw width is set to idle, our speed is setting itself to 0. We don't need to set speed because we already know speed is set to 0. But we do need to make sure that our frame is pointing at the right spot. And then we can animate idle. Animate idle, game time. Finish you off. Else, if our speed is not equal to 0, then that means our player state is walking. So we'll put in here. Therefore, we are walking. And if we're walking, what do we need to do? Well, we need to move, so we better update our position. Position. And we need to constrain to screen. And then we need to animate walking. Which of course needs game time passed in. There we go. And if we have updated our position, then we'd also better check for our layer depth. So we'll put in here get layer depth. Get layer depth. So we make sure we're drawing on the right layer depth area in case we've just moved up or down vertically, and now we're in front or behind one of the enemies. That finishes off you, and that finishes off you, which finishes off the move. Have I got space? No, I don't. Let's go back up and make ourselves another whiteboard sheet. Whiteboard sheet. And in this one, we're going to look at the animations for both jump and walking. So let's look at the jump one first. Private, void, animate jump. Which of course takes in a game time. Here we go. What have we got to do? Well, our draw width has already been set, our origin has already been set, so all we really need to do is update our current frame time. This one I'm going to write out. It's pretty simple, but it's slightly different. We'll say current frame time equal to float game time dot elapsed game time dot total seconds. There we go. Have we gone over our limit? Current frame time bigger than or equal to actor dot frame time dot frame rate. And if we are, then we'll say frame x plus plus. There we go. But then we've got to check, have we gone over the limit of our animation? So if frame x is bigger than, how many do we check for? Let's go into our reacts. 0, 1, 2, 3, 4, 5. If we're bigger than 5, but if we go past 5, if we loop the animation, that's going to be a bit of a problem. So if we've gone past 5, we're just going to say, well, then in that case, frame x equals 5. There we go. Don't go over if you don't have to. And that'll fix you. Finish, finish. That'll be 1, 2. That'll finish you off, essentially. And then we need to set draw area. Well, I guess we should put draw area back up here. Set draw area. If we've just changed frames, and that'll finish you, and that'll finish you. Okay, that's our animating the jump done. So let's take a look at our animating of the walk. This one's going to be a little different to the other two. Private, void, animate walking. Game time. I think I may have called it animate walk in the previous sprite sheet. Not sprite sheet. Lesson plan. Better check it out in case we did. Did I? Animate. No, I called it animate walking. It's all good. It's all good. Sorry, I thought I called it animate walk. And that would have been kind of strange, suddenly calling this one animate walking, because then I'd get a compile error saying that the method does not exist. Well, I typed it incorrectly. What we're going to do is set our... We're going to check, are we on the correct Y frame? So check it out, not React, the other one, this one here. Let's say we've just come from we're on U, our idle, and we've just tapped over to the right. Our frame X is equal to 0, but we didn't set that when we tapped it in our move method. So if we set it to 1 whenever we've tapped the stick across to the side, that's going to give us a bit of a problem, because that means it's always going to be set to 1. It's going to loop there, it's a bam, and then it's going to go, okay, you've finished that one, I'm going to move on to number 2 now, and it'll go to number 2, but then the next update it'll say, but hang on, I was supposed to be 1 because the thumbstick's held down. Bam, it'll go back to there, and it'll keep on looping itself on 1, which will give us a bit of a problem. So what we're going to do is take care of that one by saying if frame Y is not equal to 1 and frame Y is not equal to 2. So if it's not equal to 1 and it's also not equal to 2, then we're going to set frame Y equal to 1. There we go. That way we can still play with our animation. We can loop ourselves to go from across in X, hit the 1, let's bring it up. We can now go from here, blah, 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 boop. Okay, cool. Down to the next one. Here, when it finishes the animation, loop it back up here, go across. When you finish the animation, go down to the next one, finish, and so on and so forth until we didn't want it to stop. And that's what a cool little line that is. There we go. Now the same way can be done from before. Current frame, we'll just put in here, update frame time. Oh. Update current frame time. And then we'll say, if we have gone over the limit, so we'll put current frame time bigger than or equal to actor dot frame rate. And if it is, then we'll set current frame time equal to 0. Current frame time equals 0. Boom. We'll say frame X plus plus. And if we have gone over the limit there, then we'll say if frame X or frame Y is equal to 1, then we'll say frame X plus plus. What am I doing? I'm a little lost here. Whoa, let me get rid of that. There we go. If frame Y is equal to 1, then we'll do another if statement. What was I thinking? If frame X is bigger than 7, where'd you pull 7 from, Richard? It's going to our character attacks. 0, 1, 2, 3, 4, 5, 6, 7. If frame X is equal to 7, then we need to set frame X equal to 0. And frame Y equal to, well, we don't even say Y, we just say equal to, we say plus plus. There we go. Now our frame Y is going to be equal to 2. There we go. And we can say else, yeah, I'm spelling else right. Else, so that means our frame Y is not equal to 1. Not equal to 1. And if it is not equal to 1, what do we do? Finish that one off, we finish open U, and we can say if frame X bigger than 7, looks like 7, 7, or bigger than, but no, that's bigger than 7. I guess I'll finish you off. There we go. I've never written 7s like that before. I think they're kind of strange like that. Let's say frame X equal to 0, and our frame Y minus minus. Boom, boom. What's that going to do? It's going to, okay, we've gone along frame X, we check it. Have you over 7? Are you over 7? Are you over 7? Are you over 7? Yes, I am. Okay, well, your frame Y, what is it? Well, frame X plus plus. Am you bigger than 1? Or are you equal to 1? Yes. Well, is your X bigger than 7? No, it's not. Well, then, doesn't really matter. Just go back away. Frame X plus plus, frame Y, is it equal to 1? Yes, it is. Is it bigger than 7? Is your X bigger than 7? Yes, it is. Well, then frame X is equal to 0, and frame Y plus plus. But then down here, if it's not equal to 1, that means it's going to be equal to 2. Because if we come back up here, we made sure of that. If it's not equal to 1 and it's not equal to 2, well then we set it to 1. So we always start our animation from there. And we go across and we go across and boom, if we finish U, then we go back up there. And that takes care of our animate walking. And I guess if we've done all that, we better set our draw area. Where are you? You were update frame rate. Yep, good, we're in the right spot. Set draw area. Close you, close that, close the method. Righty. Oh, and that's our animate walking, and that's our animate jumping. And is there anything else I'm missing in this thing? I don't believe so. Oh, yes, our draw call. Our draw call is going to need a bit of an update here. We'll put this on another one. Sorry, I scrolled down. Thought there would have been some space, but there wasn't. So new, here, okay. Public, void, draw. Taking in our sprite batch, and our sprite batch had. What are we going to say? We're going to check. Are we jumping? Are we jumping? If we are jumping, then we need to draw our character using the jumping position. And then we come down here and say else. Well, that means we're not jumping. We can draw using the normal position. Oh, I guess we won't say normal. We'll say actor dot position or this dot position. Because this is also pointing to the actor itself, which has a position inside it. An actor does not have a jumping position. And that is all we need to add into our draw method there. And the other thing we need to do inside our draw is make sure we're drawing our character facing left or right using our draw facing, which is a simple sprite effects.flip horizontal. And that is everything we need to do there. So, in the next video, it's time to start coding this thing out, guys, and get this thing up and running. I'll see you there. Bye-bye.